Good evening. I'm Ludo Diels. I'm professor at the Antwerp University, and I will explain in a few minutes how the Antwerp University and the Research Institute VITO are collaborating in India. And especially we are working on the study of the water quality of the river Ganges and developing a new waste and wastewater treatment system that we call Andikos. We do this in collaboration with the Indian Institute of Technology in Kanpur, which is an institute on the river Ganges. And we also do this in collaboration with our Indian partner Ion Exchange and with a Belgian SME, Blue Food Membranes, which is a spin-off of the VITO Institute. When we look to the river Ganges, we see that it gives water to 600 million people. It has a very high flow rate, although it is seasonal. And nowadays we see that there is an increased pressure on measures due to the very high contamination, which is not only due to the wastewater discharge, but also, as you see in the upper picture, due to the presence and the flow of a lot of dirty waste materials into the river. In the figure in the bottom, you see the COD of the Ganga River along the flow, and then you see that every city has increased COD concentrations, and in the square you see the situation for Kanpur, which is a very highly densely populated city, but also with a strongly industrialized system. Especially we have there more than 500 tanneries that are all discharging to the river. So you can imagine that it is quite important to work on these treatment systems. Speaking about treatment, it is we selected a system that is working on anaerobic treatment, because anaerobic treatment will produce biogas which can be transformed into energy. If we go to an aerobic treatment, we will consume a huge amount of energy and only produce CO2. However, current organic levels in sewage are between 0.1 and 0.5 per grams, and this is not very optimal to induce strong fermentative processes. These require more than 5 grams per liter. So therefore we decided to enrich the sewage water with energy and carbon-rich streams, and we call that Andikos. Andikos stands for anaerobic digestion by combining organic waste and sewage. And it means we try to concentrate either the sewage via membranes, or we enrich with organic matter, for instance, from kitchen waste. Or we can do also a combination too. In this slide you see that we take the sewage water, it's number one, that we filter via the blue food membranes, which are IPC membranes developed at VITO, and this gives a concentrate, and on the other end a permeate, and the permeate is nearly clean and can be discharged, whereas a concentrate can be used to go to the anaerobic digestion. And you see here that about 85% of the COD is removed, nearly all the BOD is removed, as well as the total suspended solids, and some nitrogen is also removed. Overall, you see that Andikos looks like you have a sewage system that you treat with a membrane separation. 90% of the water is immediately purified and can be discharged or used for irrigation, because it's also free of any bacteria and viruses, which is very important for irrigation. This concentrate is then combined with organic solid waste, like kitchen waste, in a system that was developed by another Belgian SME, Europem. This system is removing clean sand and grits, some plastics and stones and so on. Then after mixing, it is transformed to the anaerobic digester, where it produces biogas and electric power from the gas, and the digestate can then be transformed via conditioning in nutrients and organic fertilizer. And here in this slide you see the Andikos installation in Hyderabad, where we are working on the combination between sewage and kitchen waste. This is a place where about 100,000 lunches for school children are prepared every day, and so the kitchen waste is transformed together with the sewage water in this big fermenter and produces quite high amounts of biogas that is transformed into electricity, which is then a renewable electricity. In Kanpur, we develop the membrane filtration and the subsequent treatment in an anaerobic digestion, and this is ongoing in the framework of a collaboration between Europe and India under the name VITO India, where we are focusing on the treatment of the wastewater in combination with the production of a quality water for anaerobic digestion and the production of as much as possible renewable energy. And I believe that together with the students in Antwerp, we can really make a big difference, because the development of waste and wastewater treatments together in one combined system will strongly help us to make rivers in developing country resilient, so that they can also participate more in the cleaning of some contaminants in the water, and it will help a lot to keep the water quality as good as possible, to make it a new water source for the other villagers in other places around the river and so on. I would like to thank you for your attention and really believe water is our global common. We have to work on it. Thank you so much.